Okay, ji. So now we have this example in which your h of omega, your uh, transfer function, it is given to us as 200 j omega over j omega plus 2 into j omega plus 10. So first thing first, that in order to plot the magnitude and the phase plot of this uh, transfer function, so we have to convert this whole equation into a standard form. And in order to convert it into a standard form as well, so I can take 2 out from this thing. So it will be, I can take 2 out over here, so I can have 1 plus j omega by 2, and I can take 10 out of here, so I can have j omega by n over here. So this will be 200 over 20 into j omega over 1 plus j omega by 2 into 1 plus j omega by 10. So this is 10 over here, so the final answer, it will be 10 j omega over 1 plus j omega by 2 and 1 plus j omega by n. So this is the standard form of your h of omega. So now from this form, I am going to compute the magnitude and the phase as well. So I can represent, so the magnitude of this whole term, it will be n magnitude of j omega over magnitude of 1 plus j omega by 2 into magnitude of 1 plus j omega by n. So this is the whole magnitude of this thing. And the angle, now I'm talking about the angle. So the angle will be, so this is a constant term, it is a k, and as you already know that the angle of the constant term is 0. So basically 0 degree plus, so what is the phase angle of the 0 at origin? So it will always be positive 90 degree for all the values of omega. Okay, so these two are the phases of the numerator minus the phases of the denominator, which will be minus tan inverse of imaginary over real, so it will be omega by 2, and again it will be minus tan inverse of omega by n. So this is the phase. So now in h in EB, it will be equal to, so I can take the individual one, so it will be 20 log 10 of 10 plus, so these two will be added, so 20, because these two are multiplying with each other. So if I want to take the individual logs, so I am going to add them. So 20 log n of j omega, and these two are in denominator, so minus 20 log n of 1 plus j omega by 2 minus 20 log 10 of 1 plus j omega by 10. So this is the HEB equation in the dB form, and my final phase, it will be 90 degree minus tan inverse of omega by 2 minus tan inverse of n by 100. So now how I'm going to plot this whole things over here. So here I can say that I'm going to plot the individual terms first and then add them in every decade as well. Okay, so the first thing first is this whole term. So 10 log 10 of 10 which is equal to 1, so its answer it will be 20. So I can have a positive 20 value for all the values of omega for this constant term. Now the next term here is the 20 log 10 of j omega, and as you already know that it will be a plot something like this one, and so on and so forth. So this is a plot of 20 log 10 of j omega. Okay, and this is the plot of 20 log 10 of 10. So these two are the individual plots of these two. Okay, so now this is a single order pole as well, and it will start from its corner frequency. So it is 1, so the corner frequency is 2, so it will start from 2. And so if it is start from 2, so the decade is its next decade will be at 12, and the next decade will be at it's the next decade will be at 20, and the next one will be at 200, and then 2000 as well. So from minus 20, like I say, this is minus 40, and so on and so forth. So it will start from 2, it will remain 0 until 2, so I'm talking about this one, and from 2 till 20 it is minus 20 dB per decade, and it will keep on increasing, and at 200 it will gonna reach at minus 40 dB. Like I can say that this is my minus 40 dB, and it will keep on increasing like this one. Okay, now what is the plot of this whole thing? It will start from 10. It will start from 10 and up till 100. It will reach at minus 20 dB, and from 100 to 1000 it will reach at minus 40, and so on and so forth. So this is the plot of minus 20 log 10 of 1 plus j omega by 2, and this is the plot of minus 20 log 10 of j omega by 10. So now I'm going to add them all. If I'm going to add them, so as you can see over here, on every decade I have to add all the values. So one plot is one values is minus 20, and the other values is positive to 20 for this one. One is this one, second one is this one, third one is this one, and the fourth one is this one. So these two terms, it will be 0 on 0.1, but you have a minus 20 and positive 20 over here, so you will start from 0 dB, because if you add them together, so you will start from 0 dB. Okay, so now after 0 dB, so it will be at 0. So and your whole term, it will be, but it is now this is a constant term, but this one it is increasing. So from 0 until 1, so it will reach approximately from 0 to 20 dB, because this one is increasing. So at 1, so as you can see over here, at 1, so the value of this 0 at origin, it will be 0, but the value of this constant term, it will be 20. So it will be starting from 0 dB, and at omega is equal to 1, you will reach at 20 dB, and after that it will again keep on increasing until So until 2 it will again keep on increasing with the same slope, and at 2 you have a decreasing slope until 10 over here. So you can see that until 10 you have a 20 dB increase, and you have a minus to 20 dB increase as well. So this is increasing and this one is decreasing. So this one will be flattened out up till n, and after that there is a third there is a second pole which is starting at 10. So it will be keep on decreasing with a minus 20 dB slope, and it will reach 200, and at 200 it will cross, and then it will be in the negative side of this. So I'm just adding, like in this thing I'm going to add this one is 0, this one is minus 20, and this one is positive 20. So this one will be 0, and again you will add a positive 20 over here, so it will be a flat line over here as well. So this add line, it will be basically the addition of all these terms. In the same way, we can say that our phase plot, it will have a 3 terms in it. So one phase plot, it will be 0 degree, positive 90 degree, minus 45, minus 90, plus 45, plus 90, minus 135, minus 180, and plus 135, and so on and so forth. So you can observe over here is that okay. So now this is the one term. So you have a single phase for all the values of omega, and this is for this thing, and then you have a pole at corner frequency equal to 2. So basically from 2, and it will start from 0.2. So it will keep on decreasing, and at 2 the angle will be minus 45, and 2, and on 20 its angle will be 90 degree, and after that it will remain at 90 degree. It is for this one, and for 10 it will start from 1, and it will reach n at an angle of minus 45 degree, and on 100 it will reach on minus 90 degree, and then it will remain on minus 90 degree as well. So now I'm going to add them all. So here all the things are 0. This one is 0, this one is 0, but this one is 90. So answer will be positive 90 until 0.1, and then it will keep on decreasing until 1 to 45 degree, and from 1 to 2 it will keep on decreasing, and it will gonna pass from this line, and it will reach on minus 45 on 20, and after that it will reach on positive minus 90 as well, and it will be 0. So you can observe over here as that at 100, so these two poles are adding minus 90 and minus 90 angle, so total will be minus 180, and you have a positive 90 over here. So the overall, so the final angle will be minus 90 over here, and here in between that you have a slope, because these two are decreasing at a rate of 90 degree per decade. So these two are the final plots of your magnitude and phase plot of this example.